Okay, and a good morning to everyone. And surprisingly, what you were listening to is the Rolling Stones. And you'd recognize it by the signature song. I asked Sarah, what song did she feel that would be a signature for the Rolling Stones? And she said Satisfaction. So we went to the CD collection last night and we looked for the album that seemed to do that, and this one's got to go back to when the Rolling Stones were still doing blues stuff, and they don't sound like the, that amplified sound. They were at the Super Bowl, weren't they, this year? This last year, I think they were, and boy, they had a more raucous sound than that. So I'm going to have to see if Sarah has Satisfaction with a little more of a current Stones sound. Can't have no satisfaction, I think, is the way the I can't get no satisfaction. The grammar really leaves something to be desired. And I have a hunch that it's been changed in the more recent versions to something even less grammatically correct. At any rate, signature performance by a legendary group that's still performing, the Stones. You had a quiz yesterday on 1 through 6, and I have that graded and returned to you. And then you had review test 6, that's been graded and returned to you. And you just turned in review test 7. Now the question, as you look at the quiz, the question is, what kinds of things do you see on the quiz that you should review? Because a quiz serves several different functions. One, it certainly gives you a grade. And if your grade isn't as high as you wanted on the quiz, the question, how does that affect your semester grade? Keep in mind, you have 18 review tests at 100 points each, 3 quizzes at 100 points each. So that's 2,100 points. This is 100 out of that total. So this doesn't destroy you, but it gives you some messages. If you see that you have trouble with prime factoring, it tells you to go back and spend some time on it. If you had trouble expanded notation, or grouping by tens, or you have problems with short division, it's giving you feedback, and you need to listen to it and spend some time on it. But it doesn't mess you up in terms of your overall grade. It may have told you that you aren't working as fast as you should. And if that's the case, then you need to practice. We're going to have another opportunity at the end of the 13th review for another 20 minutes on fractions. And then when we get done with 18, we're going to have another quiz on decimals. So time is a critical issue here. You do need to practice. Now, based on what you see, are there questions about any of the processes that we need to answer as you look at what you did and still have questions? This is now 1 through 6 on the quiz I returned to you. Is there anything there that you want to ask about, or you're still feeling that needs to be reviewed? Okay, on lesson 7. I ask you to reduce fractions using primes. How did that go? And if you have 7, you need to pass it on down and get it over to me because I've already collected it. So 7 has been collected. Thank you. Are there any problems with reducing a fraction using primes? So I should assume that's a comfortable thing. Okay?
I had a question on the quiz. The product of primes.
Product of primes problem?
I keep getting big numbers.
Okay.
And I got it wrong, so I know I'm doing
Let
it
me
wrong.
do something very close to that problem. Will you write this number down for me? 1045. 1045. Now this is just a number I pulled out of my head the last hour. But I'd like you to try dividing by primes. Start with the 2, then the 3, then the 5. While you're doing that, I'm going to write the primes on the board, and I'm going to write the number on the board, and then maybe we can look at it together. But my number again, 1045. And the directions would be write as a product of primes. That would be the direction, to write as a product of primes. So I'm going to put the problem on the board. So write 1045, which technically is 1045, as a product of primes. That's my problem.
Yeah, I got the same number on quiz too.
I know you did. That's why this turns out to be such a delightful problem.
So a lot of people had a problem with that one then?
Yes.
Oh, good.
The comments that are going on here, this is similar to a problem on the quiz. Did a lot of people have problems with it? And the answer is yes. And you're going to see why in a moment. But we write the primes first, correct? Oh, a short list. Doesn't have to be very long typically. Okay, I'm going to go down to 17. And I want to start dividing by the primes in my list. Now, I'm admonishing you to start with the lowest number in your list, because it'll help you decide whether you're done or not. So the 2 is what I'm interested in. I'm putting the 1045 here, trying to divide by 2, and what conclusion do I make about the 2?
No.
Won't work. Why?
5.
Not even. It ends in a 5. So the 2's out. Now do it in order. I know you want to go to that 5 right out of the gate, but do it in order. So can I divide this by 3? What's my argument? No is the correct answer, but what's the argument?
Something but
The
3.
digits, 1, 0, 4, and 5. Add them up.
10.
You get 10. Does 3 go evenly into 10?
No.
The answer is no. So 3 is not going to divide this. So I'm done with 3. And that 5 you were so impatient for can create you a headache really fast. Because 5 goes into 10 twice, and 5 won't go into 4.
0.
You have to put that 0 in. Some of you put a 9 in when you got to that in your quiz. Made an error. So we get 209. Will 5 go into 209? No? Didn't end in a 5, so no luck. What about 7? Well, I don't know that. And I don't know 11, and I don't know 13. What I do want to ask, before I go any further, when can I stop? Well, let's do this. 15 squared is what? Shortcut time.
225.
It's a 225. It always ends in a 25 if it ends here in a 5. And how do I get the first number? Take this times the next higher. Don't double it. I take the 1 times the next higher, which is 2, so I get 225. What does that have to do with when I can stop? Okay, I can stop here because 15 squared was bigger than this number, so 17 squared is going to be bigger than that number, so I don't even have to do 17. I only have 3 numbers to check. If I started with the smallest, I've gone down my list, and none of these work now, I'm done. And I know that this number is prime, and then I have to do what? Say 5 times this equals my 1045. But that's anticipating things that aren't true. Will 7 go into 209? Let's try it. So I take 7, do a division. 7 goes into 20. How many times? Twice. What's left over? A 6, correct? So I put the 6 next to the 9. Will 7 go into 69 evenly? The answer is no. 7 times 9 is 63. I'd have a leftover. So that didn't work. So 7's done. So I'm going to get rid of this 2. I'm going to get rid of that 7. And I'm also going to get rid of this eraser. Let's try one more time. Trying to get rid of the shadows there from the chalk. And I'm getting rid of this 6. Okay, 7 didn't work, so what am I going to go to? The next prime, 11. Okay, it goes one time. What's left over? What's 11 from 20? 11 from 20. It's a 9. 10 from 20 would be a 10. So 11 from 20 is just one less. That's a 9. What's 11 into 99? A 9. You're grumbling. Now, 19 is prime. Then what must I do? I'm not done yet. One more step.
9 to the first power times
9?
19.
Oh, 19. Okay, so I have 1, 0, 4, 5. I think I'll reverse them and do them in order and size if you don't mind, but you are correct. 5 to the first, 11 to the first, 19 to the first.
Question, if you were to put to the first, is it wrong? That's wrong.
If I did what now?
But you didn't put it to the first.
Oh, if I didn't put the ones on there, the answer would be correct. But if I ask you to use exponents in your answer, then I'd want to see the ones. Now, the reason for that, wanting to see the exponents, I'm going to use primes to find common denominators. So it's nice to see those exponents. Typically, I just write 5 times 11 times 19. Okay? Any other question on that problem? You're going to see these again. In fact, for the review test you have tonight, you're going to be doing again, writing a number as a product of primes. That's what you do. And you're going to reduce fractions using primes again tonight. So I'm starting to come back and review topics that we did in earlier lessons to try to keep you remembering things. Any other question on this one? Yes?
Question on that one, but on our review test that we just turned in, on the last ones where we had to divide them and then the remainder turn them into a fraction, I had no idea what to do.
Okay. This, if you didn't hear the question, and I was admonished at 7 o'clock to repeat questions, on the review test where you're supposed to divide and you end up with the remainder and you write the remainder as a common fraction. Okay. Simplest example I can give you. That's a division, understood. We usually write it as a what? That's an improper fraction right now, and what do we typically do? Don't have to, but you can write it as a mixed number. So don't you, in essence, say 3 into 7 goes 2. You have the 1 left over, and we just say as a mixed number it's 2 1/3. That's a game I wanted you to play, but with larger numbers. So let me give you this division. And there's a wrinkle at the end that's a little bit different than what I did there. I'm going to take 12 into. 12 goes into 1,720. Now, we sometimes use the phrase goes into. I had a colleague who's now down at Cal State Fullerton, or no, Cal State Long Beach, who gave a lecture on gazentas. Was on division. Something goes into, so he just said gazentas. Same idea. Okay, short division. What are we going to do? 12 into 17? 1. Left over? 5. Now we're using short division. You are allowed this if you wish, but then you put the leftover up here. So the 52. 12 into 52?
4 times.
The 4 times. That's a 48. What's left over?
4.
A 4. I've got the 4 there. Now 12 into 40. 3. Good. 36. What's left over? The 4. That's my remainder, correct? So I do the 4 over the divisor of 12. But you're not done. I can reduce the 4 over 12.
Were we supposed to do that on our own?
You're to reduce all fractions. So this would be 1, 4, 3 and 2 over 6, which is, go further, 1/3. So when I see this 4 over 12, probably the best way is to just divide 4 into 4 and 4 into 12. But you could say 2 into 4, 2 into 12, then you get 2 over 6, which eventually goes to 1/3.
We didn't really go over this yesterday.
We did this part here yesterday. Now, all fractions are supposed to be what? Reduced. We did talk about reducing fractions.
I'm talking about the remainder.
Well, the,
On the
okay, but the part was, here's an assumption.
three.
See, I make this assumption
Read lesson?
that you read the lesson, that you go through and read what's there. And it is covered there and produced there, and I may not hit every wrinkle. I may not tap every whistle and bell, but if you have read the lesson, it should be covered there. And so, read. Okay. That brings up something that I didn't do yesterday, that with a bit of chagrin, I realized when the morning was over, I did not collect your books. So, given that I didn't get that done, and I'm not giving another quiz that allows me to collect them, and I have you working them, here's what I'm going to do to cover that. Here's the first piece of information, the office hour. It's 1 to 2:30 p.m., Monday through Thursday. And I'm here after class this morning. And so, either for the first few minutes after we finish this morning, or during office hour, you bring your book by. And I will go through your book, and it must be done by Thursday. And I will take time to look through your work while you're watching me and give you an okay and sign it. And the next time we'll try to remember to collect your book while you're having fun. So I knew it was relaxed yesterday, and I couldn't think out, why am I feeling so relaxed? I wasn't going through all your books while you took the quiz. Question?
How much is the book?
Okay, the question, how much does this count if you don't have it done? Quite a bit, because I give you 0 for everything related to those
But if
6
it is done?
lessons. So if you don't get an okay, you have a 0 on your review test and a 0 on your quiz. But you then, if I say it's not done, I give you an opportunity to go back and make corrections and get it done. So I'll put an okay, I will date it and initial it if it's okay. If not, I will hand it back to you and say, try again, and you get to bring it back again.
So
But
if it is done, it's worth just.
well, if it is done, you get credit for everything you're doing. If it's not done, you get nothing. So it's the difference between failing and passing.
Okay.
So it's a pretty big choice.
It's
If you're
done,
done, you
there's
can
just
turn it
asking.
in. It says due by Thursday, right?
Okay, the question is, if I'm done, can I turn it in right now? The answer is no. Again, here are your choices. One more time. I will be here after class for a period of time, and you can stay with me, and I will go through it with you while you're there, and okay it if it's all okay, and sign it. If not, my office hour is 1 to 2:30 today, tomorrow, and Thursday in 270C next door. That's Founders Hall, 270C. So that is Founders Hall, 270, which is not prime, and can be divided by 2 and 5 and 3, and it has a C in it for curl. So 270C, Founders Hall. So come by my office, and I'll go through it then. You have 3 days to do that. Okay? Any other questions on that? And I apologize for not doing that yesterday. I feel badly. Some of you feel maybe relieved, and others feel cheated. We had it all done, and I didn't collect it, and others say, thank God he didn't. It gave me another day to work on it. Any other questions from the review, the quiz, the lesson 7? The one I haven't been asked is the one that surprises me. Reducing using primes. That went okay? Everybody was happy with that. Okay, I will believe you until you show me otherwise when I return that lesson tomorrow. Okay, new material. Let me ask you a question. Why do we change fractions? Why do we change what a fraction looks like? And there's silence.
For a smaller number.
Okay, for a smaller number, let me look at some of the things that we're worried about here. We had 4 over 12. We changed it. Agreed? Now, the reason we changed it in this case is because when you have a fraction, you want it written in what form? Lowest form, which we call reduced form. We don't want a common divisor. Now, you know what primes are, correct? You can only divide a prime by 1 and itself. Nothing else works. If I have this fraction, (3 over 8). I have 3 over 8. It's reduced, agreed? 4 over 12 wasn't, but 3 over 8 is. 7 over 12 would be reduced. So these are reduced.
So if it can't be divided into each other.
Oh, if I can't find anything that will go into both the numerator and the denominator other than 1, we say it's reduced. Now, we say the following. 7 and 12 are relatively prime. The only thing that divides into both of them is 1. So we say they're relatively prime. These two numbers are not relatively prime because they can both be divided by 2. What else?
Which ones?
These two numbers, 4 and 12.
2, 3.
4.
Can you divide 4 by a 3 evenly?
Oh, 3 now.
4.
Okay, 2 or 4 are my only two numbers, correct? So they are not relatively prime. They can be reduced. And we saw what it became. It became this 1/3. We are expected to reduce fractions. It's a kind of standard operating procedure. Reduce a fraction. Now be cautious, because I want to again bring up something we talked about yesterday. If I have 7 over 3, we talked about that earlier, that is reduced. Now you may choose to rewrite it as a mixed number, 2 and 1/3. But that's not reducing it. So you have to make clear in your head that when you have an improper fraction and you decide to do this, that is rewriting it. It is not reducing it. So I have 7 over 3 or 2 and 1/3. That is not reducing. Now when do we, other than this, when do we want to change a fraction? Well, let me give you something that's in lesson 18. Don't expect you to turn there yet, but just lesson 18. I'm going to give you, let's say, 3 over 4. Now that's reduced, correct? Nice, common fraction, proper, behaves well. But I'm going to ask you to do this for me. I want you to change it to a new fraction with the denominator of 100. Now, to change fractions, we're going to use, in this lesson, and it's something we always use, something called the basic principle of fractions. The BPF. The basic principle of fractions. Now, in a very simple way, it says that whenever you have a fraction, remember the top part is called the what? The numerator, the bottom part? The denominator. Whatever you do to the top has to be done to the bottom, and you have two choices. What are the two things you can do? You can multiply or divide. Again, the basic principle of fractions says that you can change a fraction by either multiplying or dividing both the top and bottom by the same number. And we avoid zeros. We don't divide or multiply by 0 for this thing to work. So we come back to here. What do I have to multiply by 4 to get the 100? What can I multiply by 4 to get 100? 25, agreed? Or you could just divide 4 into 100 and say 25. 4 quarters is your 100. So I multiplied here by 25. I multiplied here by 25. Agreed? What does that give me in the top now? 75, 3 quarters. Before we had the computer, we had word processors, and we just had good old-fashioned typewriters. I assume you've all seen a typewriter at some place. Garage sales, museums. Okay. Yes, they can be considered that old. We have one at our house, and Sarah says, take this to the garage. We don't need it. Got a computer. But if you had an old-fashioned typewriter, you wouldn't have wanted to go to a new line. So you would have created what's called a shilling fraction. A shilling fraction looks like this. Everything's in the same line. So you have that forward slash. About the only place you see now that kind of thing is on a computer, when you have the URL for a web page. Early on, when you did this by hand, and you were writing this to put over 100, there was a shortcut that was used. Here's what your 100 looks like. And we then called it percent. 75 per 100. 100 is a century, so 75%, and we use this symbol. So when do we want to change fractions? When we want to write them as percents. That's one place. Okay? So writing a fraction with a new denominator is what it's all about with percents. We want to add fractions and subtract them. In order to do that, we need the same denominator. We have to find common denominators when they aren't the same. So if I look at this problem here, and I just do this problem for you, 1 over 3, and I want to add to that 1 over 4, I can't add these two fractions because the denominators are not the same. Now the shortcut, when these denominators are relatively prime, remember what I said about relatively prime? Nothing in common. They can only be divided by a 1. If they are relatively prime, you can get the LCD, this least common denominator, or lowest common denominator, just by doing what? Multiplying them together. And in fact, some people in Europe and other places may just find their common denominator by multiplying all the time. In the United States, we focus on the LCD, the smallest common denominator. And in this case, it'll be a 12. And then you want to do what to both these fractions? Change them to something over 12. And then you add. Now that's not something I want to do right now. That's the next lesson. But the idea of adding fractions does require that the denominators be the same. They aren't here, so we need to change them. And that's why the basic principle of fraction will be used. Now if I want to change these, it's pretty straightforward. The 1 over 3 becomes what? Over 12. 1 over 3 is something over 12.
4.
4 over 12.
Oh, so you just add up?
No. I think I better continue with this because I'm seeing some looks that don't make me feel comfortable. Okay, how do I change the 1 over 4 to something over 12? 4 goes into 12. How many times? 3, and 3 times 1 is 3, so that's what this problem becomes. So I have 4 over 12 plus 3 over 12. Then I can add and get 7 over 12. So we need to look at what we are doing with this, and as I say, we'll spend more time on that. But what I would like to do, and I'm going to, I guess at this point, Debbie, you're on what camera? Okay, go ahead to 1. Just a little different view. Same problem, and that frees up Debbie to go over to the sideboard because I want to look at the problem over there. But first, before we leave this is a pre-algebra problem. Why? I wrote it horizontally. If I wrote it 1/3 and then a 1/4 vertically, we'd think of it as arithmetic. But this is as a pre-algebra problem. So Debbie, would you go ahead and take us to the sideboard? Because I'm interested in how we write problems. And remember, the transition here is to try to eventually get to the point where you're comfortable in a pre-algebra class. Now this problem here, as I have it, 1/3 over 2/3, is contrasted to the horizontal version. But in each case, what I'm wanting to do is give me an answer with an intermediate step. This is the intermediate step I'm talking about. If the denominators are the same, you just add the numerators and then get your answer and reduce it. Now, if I write it vertically, I still have the same intermediate step and same answer. Now, I tried to illustrate why I'm doing this in this next part right here. I had a over 3 plus b over 3. Now, what I'm going to do, just eliminate that for a moment, because I am telling you that I have two numbers. I'm not telling you what numbers I have. I'm using letters of the alphabet to represent the number. Now, in the problem we just saw, if we just tweak it just a skosh to the left, there. The a was 1 and the b was 2. But if I don't tell you what the numerators are, I'm just telling you I have two fractions. Both are in terms of 3 in the denominator. The a and b can be anything. Then I ask, what's your answer going to be when I add? Well, we play the same game we did here. Add the numbers on the top, then put it over the common denominator, and that's it. You're done. That's an algebra problem. Now, I didn't have to use a and b. I could have used c and d. In algebra, we typically use x's and y's. Does the same thing. That's an intermediate step. And if I can get you in the habit of doing that right now, when you see this in a pre-algebra or an algebra class, you're going to say, I've got that. What's intriguing is sometimes in an algebra class, I want you to go this way and break it apart. So this goes in both directions. You can put them together or separate them. Okay? That's an interesting concept. Well, let's just, for the record, make sure we remember that we must do what? We must reduce an answer. So here is a 3/8 and a 7/8. And my intermediate step is 3 plus 7 over the 8. Notice I get the 10 over 8, and then what can I do? Reduce to 5 over 4. Now, the 5 over 4, question. If I have 5 over 4, can I leave it that way? Okay, I heard one no, and I heard you can, but with a question mark. I see a head shaking no. I see one head shaking yes.
You have to reduce, you just don't have to switch from mixed to...
Okay, well stated. Statement made. I have to reduce, but I don't have to rewrite. So let me get rid of some things here that are not as important to what I want to say right now. I have a 5 over 4. I have a choice. The choice is leave as 5 over 4. Or rewrite, notice the difference. Now, I find many people want to say I'm reducing at this point, and that's not the correct statement. I'm rewriting as 1 and 1/4. That wasn't reducing anything, that was rewriting it. There's a distinction between the two. Now, question. Are they both valid? Yes. Is one preferred more than the other? Depends where you are. If you're taking a multiple choice test for a job and they give both these answers, which will the test writer typically want you to check? The 1 and 1/4. Unfortunately, that's the case. They will think that's the better answer. Algebraically, in terms of arithmetic and where we're headed, 5 over 4 is often your best form. But if I'm taking a test and a job is on the line, I will write it as a mixed number. It's interesting because you may have been told you must always do the mixed number. Not always the case. Now, let's see. The question, of course, when we're doing fractions, what do we mean by a common denominator? And where we're headed is changing, as I showed you in this. Debbie, if you'll go back to the front board where we had the last problem, the 1/3 and 1/4. Remember, that's where we're headed, to change fractions so that they have the same denominator. And so the question, of course, is how do we do that? And what I'd like to approach on that is different techniques. Now, if I did that problem, I'm going to write it over here now. I had the 1/3 and 1/4. And this is technically the next lesson, but I want to approach it so today we have time to look at it. The technique is to find a smallest number that can be divided by 3 and divided by 4 evenly. Now that turns out to be 12. I told you that if these two numbers are relatively prime, you can just multiply them to get the LCD. So this is the phrase I keep referring to. And notice the L stands for least, the C for common, and the D for denominator. Now, if you don't like the word least, what could you replace it with? Lowest. Mathematicians oftentimes try to find smaller words. They go on the principle of paucity. Here's a new word for you, which is not a small word. Paucity. And it's basically getting by with as few things as you can. So if you're looking at number of letters in a word, least has fewer letters than lowest, so we practice paucity. Here's another 3 letters, like alphabet soup today. LCM, meaning least, common, multiple. So this is still the least. The C is still the common. But this time, we have multiple. Now, I've shown you one way of getting a common denominator, and that was just multiplying these two together. By the way, the method I was taught as a kid, look up into the sky until you see it. I call it the butterfly technique. You just search the sky for numbers, and one that you want is the smallest number you can divide by 3 and 4, and you just keep looking. You know, you sort of look up into your head, eyes go upward, and then you just sit there until you see it. There's a better technique than that called common multiples. So I'm going to use the notation this way. 3x and 4x. So 3x means multiples of 3. You're counting by threes. So as you count by threes, what numbers do you get? Start with the 3. Next number if you're counting by threes. 6. Next number if you're counting by threes. 9. Next number if you're counting by threes. 12. Then 15. Then 18, and so on. We could go forever, correct? Now, if you're having trouble getting those, this just means 3 times 1. This is 3 times 2. This is 3 times 3. See how I'm getting them? And why we say 3x? Because you're taking 3 times something. Okay, let's try the 4s, counting by 4s. Well, first, 4, right? Then 8, then 12, 16, and 20, and so on. Agreed? So again, 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. These are multiples. What is common to both lists? Do we see the 12? Is that the smallest number that's common to both lists? The lowest number that's common to both lists. Hence an LCM. Since the numbers are denominators, we call them LCDs. That technique will always work. What's the downside of this technique? Can go very long. Let me give you an example. Same idea. Numerators aren't bad, but the denominators are quite large. Now, it was easy to count by 4s, easy to count by 3s, relatively speaking. You ever tried counting by 48s? It's not comfortable. Let's try first few. 48, then what's my next?
56 or 86, 96.
We can give 4 or 5 different answers and get there. 96, agreed, finally. And then what's the next one? What? 044? 144. Do we agree? Sure, anything anybody wants to say, I'll go with, right? Oh, what about here? 56, the next one? 112, good. Next one? Okay, one of you has got the idea. Do you understand you wouldn't want to do this very far? Because it's so painful? We had trouble getting the first few. So we need a better way. So what will the better way be? So we need a better way. The answer? Prime factoring, that's where we're headed. It'll allow us to get the common denominator. It'll allow us to reduce fractions. It's a powerful technique. So that's where we're headed. And that's all the way into lesson 11. Now, what are the speed bumps along the way? Because tomorrow, all we're going to do in lesson 8, what you do for homework tonight or tomorrow morning, is going to be denominators the same. Pretty straightforward. Then, in lesson 9, we're going to subtract fractions, and when we subtract them, we have to worry about this. Borrowing. That's where the speed bump is, where we can make mistakes. And the shortcut to avoid borrowing, use IPs. Improper fractions. Remember we did the idea proper, improper, mixed, so an IP, an improper fraction, not an internet protocol. So that's where we're headed. And then after we've added and subtracted, then we're going to go to LCDs with primes. And that's getting us up through the 11th lesson. The 6th one was extremely important. The 11th will be extremely important. And we will go through 13 before we hit our next quiz. So that brings up, what do we do this week? Well, for this week, and this is leading into Thursday, this week, today, we're doing what? Number 8. Tomorrow, number 9. That's, today's what, Tuesday? So tomorrow's Wednesday. Thursday. You got it. Vitamin C, the orange book. And the unit that we've been working on, counting. This will be our second major lecture on counting. The minute we hit the third one, we're ready for a major exam on the counting unit. And that's more like a full-hour exam on counting. And that is an important part of your second half grade. Your second half grade is 1,000 points. 400 of them on the final, 600 on your review tests, and 100 points from that 1,000, that's 10% of your second half grade, is the counting unit. So my point is this. Thursday you need the orange book with you. And I know that you may have been avoiding the orange book and the counting. Remember, we used nickels, pennies, and quarters. And we did problems there. We're going to spend a full hour on Thursday working on that with the idea that on the weekend you're going to try to finish the unit, have the review test done, or the unit review it's called, so that the next week we can answer questions, do a review, and get ready for a test. So that's where we're headed. This is called advanced organizers, knowing where you're going. So Debbie, let's come back to the document cam. I didn't get it set up because it's not there. Sorry, that's my error. I need to do that. Let's leave that, because what I wanted under there is to go ahead and show you, and I was thinking what I had there from the last hour. I'm going to go ahead and show you review test number 8 that you have due for tomorrow. So let's look at that. Now, Debbie, it works. That was my glitch. So review test 8. Notice basic principle of fractions. First problem. Then coming off there for just a moment as I slide down. Second problem. And third problem, you're adding and subtracting. In subtracting, the only thing that's different, your intermediate step, is what? With a minus sign between instead of a plus sign. But what I want you to note is number 4. That's from the 7th review. Using prime factoring to reduce something. And then, coming back to the 6th review, writing 1,260 as what? A product of primes, which is exactly what we reviewed this morning. So your review tests are going to start spiraling back and hitting earlier material. So review test 8 will be due tomorrow. Since I have just a few seconds here, I do want to show you what I perhaps omitted, and that is if you have a subtraction and you're thinking in terms of showing the intermediate step, this is on page 75. And here was a case where I had a subtraction. This is my intermediate step we talked about, where you see in the middle this step. I really want you to work to putting those intermediate steps in. So I want to see this step right here before you give me the answer. So with that, Debbie, we are right at the end. And we started out with the Rolling Stones, and we did satisfaction.
Now we're going to do tell me.
Okay, tell me what you know. But that's not what they had in mind. But listen to this, because the Stones don't sound like you're familiar with them now. This is way back when.